Hi students, myself Kale S.L, रयत शिक्षण संस्था RBNB कॉलेज रामपुर, 12th Science Mathematics Part 2, lecture number 1st. Topic is Application of Definite Integration, exercise 5.1. In the previous video lectures, we have completed two topics of integration, that is indefinite integration and definite integration. Now here this is the third topic, application of definite integration. So let us start here. First, area under a curve. In this chapter we have to consider only area under a single curve and area bounded by two curves, and it contains only one exercise, that is exercise 5.1, having three questions: question number first, question number second, and question number third. Question number first contains 7 problems, question number 2 contains 2 problems, and question number third contains 5 problems. So totally there are 14 problems. So let us start here. Area under a curve. The area bounded by the curve y is equal to f of x, x-axis, and the lines x is equal to a and x is equal to b is given by the definite integration from a to b f of x dx. So suppose here these are the coordinate axes, x-axis and y-axis, intersecting point origin O. Now here this is the curve y is equal to f of x, and we want to find the area under this curve. Area under this curve. So area under this curve is like this, we have to take the area under the curve. But here we have to take the area bounded by the curve y is equal to f of x and x-axis. So we don't consider this area which lie in the fourth quadrant. Only we consider the area under the curve y is equal to f of x and x-axis. Here also and the lines x is equal to a and x is equal to b. Suppose here x is equal to a, here x is equal to a, and here x is equal to b. So this is x is equal to a, means here point a and here point b, suppose. So we have to consider this area, get it? Area under the curve y is equal to f of x. So we need not here length, its breadth. We find the area of suppose rectangle, then we take its length, breadth, then we find area. Here we take to find the area under the curve the concept as a definite integration. Considering definite integration, we can find the area under the curve y is equal to f of x, x-axis, and the line x is equal to a and x is equal to b, and this is find using the formula definite integration from a to b f of x dx. Now here if we consider the curve like this, suppose this is x-axis and y-axis, and curve is like this. We consider this curve as x is equal to g of y, suppose. Means the area bounded by the curve x is equal to g of y, this y-axis, and the lines y is equal to c and y is equal to d. It is given by the definite integration from c to d g of y dy. Suppose here y is equal to c, suppose here, and here y is equal to d, and we want to find the area under this curve x is equal to g of y, and this area we find using the definite integration from c to d, g of y dy. So if we want to find the area under a single curve and the axis, we take it as a definite integral, either this formula integration from a to b f of x dx or integration from c to d g of y dy. So these are the formulas to find the area under a single curve. Now next here we find area between two curves. area between two curves. Suppose there are two curves like this. This is one curve and this is another curve. Here suppose this is y-axis and here it is x-axis and y-axis. Here origin O. We want to find the area between these two curves, area bounded by curve. Suppose here upper curve as y is equal to f of x and lower curve as y is equal to suppose g of x, and we want to find this area. Means here let y is equal to f of x and y is equal to g of x be two curves, and let A be the area. This shaded region, suppose capital A, bounded by two curves, y is equal to f of x and y is equal to g of x. Then this area is equal to, we denote it as A, suppose A1 minus A2. A1 minus A2. What is here A1 and A2? A1 is the area under the curve y is equal to f of x. Here upper curve is f of x of this shaded portion and lower curve is g of x. So firstly we find the area under the curve y is equal to f of x like this. Suppose here x is equal to A and here x is equal to B. We find this whole area under the curve y is equal to f of x. Then take the area under the curve y is equal to g of x. Means this area only. Here this area. And then take the subtraction of these two areas. We get the required area. And this point A, x is equal to A and x is equal to B, we find by solving the two equations, y is equal to f of x and y is equal to g of x. These are the point of intersection here, A and B. These are the point of intersection of these two curves. We can find this point of intersection by solving the y is equal to f of x and y is equal to g of x simultaneously. Get it? So when we want to find the area between two curves, then it is equal to A is equal to A1 minus A2, where A1 is the area under the upper curve, that is y is equal to f of x, that is A1 is equal to integration from A to B f of x dx, and A2 is the area under the curve, this y is equal to g of x, that is definite integration from A to B g of x dx. And then take the subtraction of these two areas, we get the area bounded between the two curves. In this way we can find the area under the single curve or area bounded by the two curves. Now here we start exercise 5.1. So let us start here exercise 5.1. Question number first. Find the area of the region. Question first. Find the area of the region. Find the area of the region bounded by the following curves. Bounded by the following curves. The x-axis and the given lines. X-axis and the given lines. First problem here. Y is equal to 2x, y is equal to 2x, x is equal to 0, x is equal to 5, x is equal to 0, x is equal to 5. Now see here, we have given single curve y is equal to 2x and the lines x is equal to 0, x is equal to 5 and the x-axis. So the area under the curve is solution. Area under the curve is, so we call it as A. Suppose A is equal to, it is definite integral. Here limits are x is equal to 0 and x is equal to 5. So lower limit is 0, upper limit is here 5, and these are the values of x. So here we take x, so here y dx. Formula is y dx. So it is equal to integration from 0 to 5, put the value of y, that is 2x dx. This is straight line. So now take these two constant outside the integral. So 2 into integration required area A is equal to 2 into integration from 0 to 5 x dx. Now here take the integration. So this is equal to 2. Integration of x is x to the power 1 plus 1, that is 2 divided by same number 2 from 0 to 5. This 2 and 2 get cancelled. So this is equal to, now put the value of x as 5. So 5 square minus put the value of x as 0, 0 square. So 5 square, that is 25, minus 0 square is 0. So this is equal to 25. And since it is area, we have to write the unit. Here write unit as a square unit. Square unit. Now here see y is equal to 2x and x is equal to 0, x is equal to 5. So single curve and two lines and x-axis. If we want to draw the figure, suppose here these are the coordinate axes. Now we know that y is equal to 2x. This is the linear equation in x and y. So it is the equation of the straight line. When the power of x is 2, 3 and so on, then it is the equation of the curve. Here the power of x and y is 1, so it is the linear equation, so it is straight line. And also there is no constant term is absent. We know that the general equation of the line is ax plus by plus c is equal to 0. And if this c is absent, then that line pass through the origin. Here constant term is not present here. So the given line pass through the origin. So suppose this is the line. Y is equal to 2x. And here x is equal to 0 and x is equal to 5. X is equal to 0 means y-axis. X is equal to 0 means y-axis. This is x is equal to 0. Suppose here 1, 2, 3, 4, 5. Suppose here x is equal to 5. And from this x is equal to 5, draw this line. So this line is x is equal to 5. Now we have to find the area under this straight line. Y is equal to 2x, x is equal to 0, x is equal to 5 and above x-axis. So this is the required area. And this required area is how much? 25 square unit. We can draw the figure like this. Now take the screenshot or copy this. Now we will see here second example. Second example, x is equal to 2y, y is equal to 0 and y is equal to 4. Y is equal to 0, y is equal to 4. So here, now here also single curve. So area under curve is A is equal to, it is the definite integral. These are the limits, lower limit and upper limit. And here lower limit is 0, upper limit is 4. And these are the values of y. So here dy. So here x. So x into dy. Now put the value of x. Without drawing figure, we can solve this problem. So if there is a question of 2 marks, there is no need to draw the figure. But if question is of 3 marks, we have to draw the figure. So a is equal to integration from 0 to 4. Put the value of x. X is 2y. So 2y dy. So it is equal to 2 outside the integral. And take the integration of y. Y as a y to the power 2 divided by 2 from 0 to 4. This 2 and 2 get cancelled. Now put the value of y as 4. So it is 4 square minus y as 0. 0 square. 4 square means 16. So area is how much? 16 square unit. Area is 16 square unit. This is the final answer. Now if we want to draw the figure of this, suppose x-axis and y-axis. Now here limits are y is equal to 0 and y is equal to 4. Also here x is equal to 2y. This is the equation of the straight line. So this is straight line. Consider this as x is equal to 2y. Now y is equal to 0 and y is equal to 4. Y is equal to 0 means x-axis. This is y is equal to 0. Means x on the x-axis, y coordinate is 0. Now y is equal to 4. Suppose here 0, 1, 2, 3, 4 suppose here. Here y is equal to 4. And draw this line. This line is y is equal to 4. Now we have to find the area bounded by area under the curve x is equal to 2y, x is equal to 2y, y is equal to 0 and y is equal to 4 and the y-axis. So this is the required area, and this required area how much? 16 square unit. Now here we see third problem. Third problem here, x is equal to 0, x is equal to 5, y is equal to 0. X is equal to 0, x is equal to 5, y is equal to 0, y is equal to 5. Y is equal to 4. Now we have to find the area between these lines. So area under the curve, area under the curve. Curve means here it is straight line. Under the curve is A is equal to integration from, without drawing figure. Here we take the values of x, 0 and 5. Lower limit 0, upper limit 5. These are the values of x. So here dx. So take here y dx. Now put the value of y as a 4. And therefore we get a is equal to integration 0 to 5 y as 4. So 4 into dx. So here a is equal to, take 4 outside the integral, and integration of 1 dx. Integration of 1 dx is x. Integration of 1 dx is x from 0 to 5. 0 to 5. So it is equal to 4. Put the value of x as a 5 minus x as a 0. So this is 4 5s are 20. 5 minus 0, that is 5. 5 4s are 20. Square unit. Square unit. This is the required area. Get it? Now we draw the figure. Suppose these are the coordinate axes intersecting at point O, origin. Now x is equal to 0 and x is equal to 5. This is x is equal to 0. On the y-axis, x is 0. And suppose here 1, 2, 3, 4 and 5. So x is equal to 5 is the line parallel to y-axis. X is equal to 5. Then y is equal to 0. Y is equal to 0 on the x-axis. Here y is equal to 0. Y is equal to 0. And y is equal to 4. So 1, 2, 3 and 4 suppose here. So y is equal to 4 is the line parallel to which axis? X-axis. Here suppose y is equal to 4. Here y is equal to 0. Now we have to find the area, this required area. Get it? And this required area is bounded by the line x is equal to 0, x is equal to 5, y is equal to 4 and x-axis. So this required area is how much? 20 square unit. We may take here, instead of lower limit and upper limit 0 and 4, here y as 0, y as 4, here dy, and put here x as 5. Then also the solution is 20 square unit. Now we will see here next example, fourth example. Y is equal to sin x, x is equal to 0, x is equal to pi by 2. So area under the curve y is equal to sin x is, area under curve is, solution, area under curve is A is equal to, we denote it by A, that is equal to integration lower limit 0, upper limit pi by 2, upper limit pi by 2, and here we take dx, so here y. These are the values of x, so here take dx, so y dx. Now put the value of y, so it is equal to integration from 0 to pi by 2, y is sin x, y is sin x dx. So it is equal to integration of sin x, it is minus cos x, so minus in square bracket suppose cos x, 0 to pi by 2. So here it is minus in the bracket cos of upper limit, cos of x is pi by 2 minus cos of x is 0. So minus in the bracket cos of pi by 2 is 0 minus cos of 0 is 1. So 0 minus 1 it is minus 1 minus minus plus 1. So it is 1 square unit. 1 square unit. So this is the solution. Highlight this solution. Now if we want to draw the figure, suppose these are the coordinate axes, x axis and y axis intersecting at point O, that is origin. Now y is equal to sin x. We know the curve sin x like this. This is the curve sin x here like this. Now y is equal to sin x curve. X is equal to 0. X is equal to 0 and x is equal to pi by 2. On y axis x is equal to 0. Now here suppose pi by 2. Here suppose pi by 2. And draw this line which pass through pi by 2. X is equal to pi by 2. Now we have to find this area. And this area is 1 square unit. So in this way we have completed here fourth problem. Now fifth problem, xy is equal to 2. Xy is equal to 2, x1 and 4. X is equal to 1, x is equal to 4. We have to find the area under the curve xy is equal to 2, x is equal to 1 and x is equal to 4 and the x-axis. So here xy is equal to 2. Xy is equal to 2. So y is equal to 2 upon x. We find the value of y. That is y is equal to, carry this 2. So 2 upon x. So area under curve is, A is equal to, it is definite integral from 1 to 4, the value of x as 1 and 4. So lower limit 1, upper limit 4, 1 to 4 dx and here y. So y dx. So A is equal to integration from 1 to 4, y is here 2 upon x dx. Now these 2 take outside the integral. So A is equal to 2 integration from 1 to 4, 1 upon x dx. And we know that 1 upon x is the derivative of log x. So integration of 1 upon x is log x. So it is equal to 2 into log x. Here 1 to 4. Now put the value of x as 4 and x as 1. So 2 into log of x as 4 minus log of x as 1. Now take here log common. So 2 into log of 4 upon 1. Log a minus log b, that is log a upon b, that is 4 upon 1. So it is 2 log of 4. 2 log of 4. Or we may take here log of 1 as a 0. Log of 1 also 0. So that is 2 log of 4. So carry this 2 as a power. So it is log of 4 to the power 2. So log of 4 square, that is 16. So this is the required area, square unit. Always write here unit, square unit. So A is equal to log of 16 if we take the log of 16 in the logarithm table, from logarithm table we can find actual area. So here put as it is, that is A is equal to log of 16 square unit. Now here if we want to draw the figure of this 1 upon x, that is the reciprocal. So x axis, y axis intersecting at origin, and here this is the curve like this, y is equal to 1 upon x. Here y is equal to 1 upon x, suppose. Now x is 1, here 1, suppose x is equal to 1, x is equal to 1. Then x is equal to 4, 2, 3, 4, suppose here. We assume this, x is equal to 4. Now we have to find this area under the curve y is equal to 1 upon x, and x is equal to 1, x is equal to 4, and above x axis. So this area, shaded region, is the area, and in the problem we denote it by capital A, and that area is equal to log of 16 square unit. So in this way we have completed here 5 problem. Now sixth problem, y square is equal to x. Y square is equal to x, x is equal to 0, x is equal to 4, x is equal to 0, x is equal to 4. Now see here, previous example are linear equations, curves are linear, that is the straight line. But here y square is equal to x, the power of y is 2, means it is curve, and this curve we are familiar to this curve. We have seen in the 11th standard, y square is equal to 4x. This is the standard equation of the parabola. So this is the equation of parabola. So area under curve, before that we take here y square is equal to x. From this we take y is equal to plus or minus under root of x. Y is equal to plus or minus under root of x. If we draw the figure, suppose these are the coordinate axes, and parabola is y square is equal to x, means it touch to y axis. This parabola touch to y axis, means parabola like this. Get it? This is y square is equal to x. Now x is equal to 0 is on the y axis, and x is equal to 4. Suppose here 0, 1, 2, 3, 4, suppose here. Draw this line parallel to y axis. Here it is, suppose x is equal to 4. Now we have to find the area bounded by y square is equal to x, line x is equal to 0, line x is equal to 4. So this is the required area. Get it? We call this as A1. This as A1 in the first quadrant. Area in the first quadrant A1, and area in the second quadrant we call it as A2. Means we have to find this total area, shaded region. So firstly we find the area A1 and area A2 are the same. So find out area A1 and take its double, which is the required area. Now here we take y is equal to root of x in first quadrant. In first quadrant, y is equal to root x, and y is equal to minus root x in the fourth quadrant. This parabola lies in first quadrant and fourth quadrant. Therefore required area A is equal to required area it is equal to this A1 plus A2. So it is equal to 2 times A1, because we know that A1 and A2 are the same area. This area and this area is same. So only find A1 and take its double. So 2 times A1. So A is equal to required area, that is equal to integration from Now x is equal to 0, lower limit x is equal to 0, upper limit x is equal to 4 and y dx. So it is equal to integration 0 to 4, y here we take root x. It is plus minus, but in the first quadrant we take plus, so plus root x dx. So it is equal to integration 0 to 4, root x means x to the power half dx. So it is equal to x to the power 1 half plus 1, that is 3 by 2 divided by same number 3 by 2, and it is from 0 to 4. This 3 by 2, this 3 by 2 becomes 2 by 3 in bracket x as a 4, so 4 to the power 3 by 2 minus x as 0, 0 to the power 3 by 2. So it is equal to 2 by 3. Now 4 to the power 3 by 2, 4 to the power 3 by 2, that is equal to 4 to the power 1 half to the power 3 using the rule of indices. 4 to the power 1 half, that is square root of 4, that is 2, and it's a third power, 2 to the power 3, that is 8. So here it is 8 minus 0, and 8 minus 0 is 8, so 8 2 is 16, so it is equal to 16 upon 3, 16 upon 3 square unit. So we get here required area as 16 upon 3. Here 2 times a1, 2 times a1, so here it should be 2, here it should be 2, here 2, here 2, here also 2, here 2, 2 to the 4, and 4 8 the 32. Here answer is 32. 32 upon 3 square unit. So in this way we have completed here 6th problem. Now 7th last problem in this question number 1st. 7th problem. 7th problem is y square is equal to 16x. Y square is equal to 16x. X is equal to 0 and x is equal to 4. X is equal to 0. X is equal to 4. Now here also it is a parabola. Y square is equal to 16x is the standard parabola, we know. It lies in first quadrant and fourth quadrant. Axis of this parabola is x-axis. So consider here, consider y square is equal to 16x. From this y is equal to plus minus under root of 16x. So here y is equal to plus minus root of 16 is 4 and root of x. So take here, take y in first quadrant, y in first quadrant, and therefore y is equal to 4 root x. Now here if we draw the figure, y square is equal to 16x, x-axis, y-axis, origin. Y square is equal to 16x means parabola touch to y-axis. So parabola is like this. Y square is equal to 16x. Here x is equal to 0 and x is equal to 4. X is equal to 0 is on the y-axis. X is equal to 0 is on the y-axis. So here suppose x is equal to 0. Now x is equal to 4. Here 1, 2, 3 and 4 suppose. So consider this as x is equal to 4, which is parallel to y-axis. Now we have to find this area. We have to find this area. That area lies in first quadrant, suppose A1, and in the fourth quadrant it as A2. So total area is A1 plus A2. So only find A1 and take its double, because this area and this area is same. So we find this area and take double. So required area, the required area is, the required area is A is equal to A1 plus A2. A1 plus A2, that is equal to 2 times A1. 2 times A1. So here it is equal to A is equal to 2 times, and now integration from 0 to 4. Lines are x is equal to 0 and x is equal to 4. So lower limit is 0 and upper limit is 4. Y dx. So it is equal to 2 integration 0 to 4. Y now we put here in the first quadrant, it has 4 into root x dx. So here it is, take 4 outside the integral, 4 to the 8 here, and integration of root x, that is integration from 0 to 4, root x here, x to the power 1/2 dx. So it is equal to 8 into integration here, x to the power 1/2 plus 1, that is x to the power 3/2 divided by 3/2, and it is from 0 to 4. Now take this 3/2 outside the square bracket, it becomes 3/2 becomes 2/3. So 8 into 2/3, and in square bracket put x as 4. So 4 to the power 3/2 minus x as 0. So 0 to the power 3/2. So it is 8 to the 16, 16/3. And here just we have seen 4 to the power 3/2 means firstly take the square root of 4, that is 2, and take its third power, that is 8. 8 minus 0. Now 8 minus 0 is 8, and 8 16s are, 8 16s are, that is 128. 8 6s are 48. So 8 carry 4. So 8 1s are 8 and plus 4, that is 12. So 128/3 square unit. This is the required area. Required area of the shaded portion. So highlight this solution and copy this solution. So in this way we have completed here totally 7 problems of the first question. Now remaining question number 2 and question number 3 we see in the next video lecture. Today we stop here. Thank you.